Hello everyone and welcome to Daily News Simplified, your one-stop solution for the detailed analysis of the current affairs which are published in the daily edition of the Hindu newspaper. Articles dated 30th of May are listed on your screen and the time stamping along with the notes in PDF and Word format are given in the description box. So let us begin with the first article for the day. This article of the Hindu newspaper appeared on page 12 and talks about the recent launch made by Indian Space Research Organization using its geosynchronized launched vehicle to put a navigation satellite in the transfer orbit successfully. Now ISRO has placed NVS-01, where NVS stands for Navik Satellite, where it is going to be put in geosynchronized transfer orbit using the launch pad at Sri Harikota, which is Satish Dhawan Space Station. Now, going by the prelims questions this year, that is 2023 prelims, UPSC has been asking random factual information. Hence, we are going to look into more details of these factual information such as places, institutions, and their names in much detail. The relevance of this topic is straightforward. In your General Studies Paper 3 in the mains examination and of course in the prelim examination, we'll get n number of questions from science and technology, and in the mains you will get more questions from the indigenization of the technology specifically. And also you should have basic awareness in the field of space. So today's content would focus upon what is this particular satellite, what it can do, GSLV and its various variants, what is cryogenic engine and how it works, geosynchronized orbits and other orbits that are used for launching the satellites, what is LVM-3 rocket, and what are the basic challenges which are faced by ISRO. So let's start understanding with what is NVS-01, which was launched recently. Now NVS, as we have called before, stands for Navik Satellite. Now Navik, from the name itself, is used as a navigation satellite. Previously it was known as IRNSS, which is Indian Regional Navigation Satellite System. It is a constellation of satellites which are used by India, although it is not a global positioning constellation like the one we have Global Positioning System, GLONASS, Galileo or Baidu 3, which are actually providing the navigation system across the world. India's Navik Satellite System or NVS is similar to the Chinese Baidu 1 and Baidu 2 or the Japanese QZSS, whereas it is providing the navigation system to the demand of Indian subcontinent. Navik satellites are used in terrestrial, aerial, marine transportation system, especially by the fishermen, location-based services, let's say cab service, personal mobility, if you are looking to find an address, resource monitoring, surveying of the land, geodesy, scientific research, time dissemination and synchronization, along with safety of life alert dissemination during the disaster management. Now, and when we talk about the time dissemination, there is important concept which is known as rubidium atomic clock, which is being used. Being an atomic clock, the frequency and the accuracy is so precise that it can further be used for the accuracy of time. Now, in the navigation system, when the satellite is far away from a personal or the person using the satellite, it is important to have the precise location as well as the timing of a particular event. Let's say you want to take a cab and the cab is using the Navik satellite system. Now, the precision of time between the cab and you should be accurate enough, and for this atomic clocks are used. Why rubidium is used? Because it is more cheaper and more efficient. Now this clock was actually developed by the Space Application Center of ISRO, which is located in Ahmedabad. Now IRNSS have two payloads. The first is the navigation payload, which is used for getting the navigation signals. The second one is CDMA ranging payload along with the laser retro reflector. The signals which are being used under this navigation satellite is L5 and the S band. Now to understand these two bands, let us look into this particular chart. As you can see, the satellite frequency which are being used are given below, which starts from L, S, followed by C, X, Ku, K and Ka band. Now, as the frequency is increasing, you can see the visible spectrum is turning from red to blue. Over and above this chart, you can see that what kind of frequency is being used. Very low frequency, medium frequency, high, very high, ultra high, so on and so forth. The very low frequency which we use through L and S band are being used for the maritime navigation signals. So this is the reason why Navik is used in this manner. On the other hand, if you move towards Ka band, you will find that it is used for telecommunication. So the concept of DTH or direct to home services that you are using right now, those satellites are very heavy and they are using the Ka band. On the other hand, FM radio, navigation aids, mobile phones that you are using frequency between K and Ka band. So whenever you get such kind of potential topics or potential areas, you should always remember this chart. This will help you to understand that what kind of frequency bands are being used by these satellites and what kind of frequency they are using in order to provide a particular service. Now from here we should now move towards understanding the concept of cryogenic engine, which was used with the GSLV in this case. So in this case, the GSLV F12 was used. So F12 is of course the vehicle in the GSLV variant. Now GSLV or geosynchronized launch vehicle is one of the high utility horse, or you can say the vehicle used by ISRO. Apart from that, we have the entire evolution of the vehicles being used by ISRO that we are going to discuss very shortly. So what is cryogenic engine that is being used by this vehicle? Cryogenic is the last stage of a space launch vehicle. Now from the last stage we mean this stage. The stages of a rocket starts from below. So this is going to be first stage, second stage and third stage. So third stage is the last stage that is going to be used for the final thrust put on a satellite. So it is the last stage where cryogenic is used, which makes the use of cryogenics. Now cryogenics is what? It is the study of production and the behavior of certain materials at a very low or extremely low temperature. So how does a material, in this case fuel, functions at a very low temperature, that is below 150 degrees Celsius in the negative or the minus format? So this cryogenics will study that how a particular fuel will act if it is below 150 degrees Celsius. So the same fuel will be used under this cryogenic engine at a very low temperature so as to provide thrust to the rocket. Now as you can see on the screen, this is a particular functioning of the cryogenic engine. So this is how the engine looks like. In the engine, the red will be the fuel. For example, you will have liquid hydrogen. Then we will have oxidizer, because in this space there is no oxygen or very minimum oxygen. So in order to burn the fuel, we need oxygen, which will act as an oxidizer. So the fuel will be burned under the oxygen and there will be the combustion which will take place in the combustion chamber. Here there will be injectors which are going to inject the fuel along with the oxidizer. Fuel will burn and there will be a throat, a narrow area, because once the fuel will burn, it is going to release energy. And when the throttle is very small, the area of outflow of the gases is small, there will be transonic gas flow and there will be supersonic gas flow. So the pressure will be very high once the nozzle is small. More pressure means there will be upliftment of heavy objects, and that is one of the reasons cryogenic is needed to uplift or to launch satellites which are very heavy in weight. The benefit of cryogenic is that it can provide more force with each kilogram of cryogenic propellant. So we need less of hydrogen or liquid hydrogen compared to other propellant like solid and other liquid fuels. The propellants or the fuels which are used includes the liquid oxygen LOX and liquid hydrogen LH2, which will act as a propellant, and the temperature which is used is minus 183 degrees and minus 253 degrees for the respective components. Now both of them are below 150 degrees, which is required under the cryogenic studies. Let us now move towards geosynchronous orbit or geostationary orbit, because GSLV was used in this case. Now geostationary orbit is the one where a satellite is put into the space. So geostationary orbit is a specific type of geosynchronous orbit. So if I have to represent this, I can represent this in this format. So if this outer part is your geosynchronous, the inner part will be geostationary. So geostationary is specific type of geosynchronous orbit where the satellite remains fixed at a specific point relative to the Earth. So when you are looking to that particular satellite in the space, it will always look like a stationary object. It will never move. While the geosynchronous, which is a larger concept, refers to any object, including, please understand, any object means may not be a particular satellite, which takes 24 hours to complete one round around the Earth. That means any object, even if it is a stone, even if it is your mobile phone and it is revolving around the Earth, then if it takes 24 hours, that mobile phone is going to take the geosynchronous orbit. But if that mobile phone is remaining fixed to a particular point on the Earth, let's say above Delhi or let's say above Mumbai, so that object will be taking the geostationary orbit. Now let us understand the basic difference between the two, that is GEO and GSO. Both are making the circular orbit around the Earth, but geosynchronous may also make elliptical orbit, which is more like this one in shape. So let's say this is your Earth and this is your elliptical orbit. The height of geostationary is 35,786 kilometers, but in the other case it may be similar or may vary. Both of them takes 24 hours. It matches the rotational speed of the Earth. That is the reason why they are taking 24 hours. GEO have a fixed coverage over a specified point on the Earth, while under geosynchronize it may cover larger area but may not be fixed. It appears to be stationary. It traces a figure of 8 pattern, which is like this. So if we trace the entire pattern of the geosynchronized orbit, a satellite would look like in this format, moving in this particular format. Then as far as communication satellite is used, so they are used for the communication. They are using K or Ka band. On the other hand, geosynchronized may also use communication, weather and other satellite patterns. And the last one is the basic disadvantage. It has limited area coverage because it remains static to a particular point. So it cannot be used for the polar regions. On the other hand, it is not fixed over a specific point. It requires tracking for the continuous communication. Now, given the complete discussion on what satellite was your launch, what kind of band was used, what kind of engine was used and which orbit was used, let us now understand the different forms of satellites launch vehicle used by ISRO. So the first and the foremost was SLV, that is Satellite Launch Vehicle 3, which has a height of 22 meters and can lift a payload of only 40 kg. Not even a two-wheeler can be put into space. Then we moved toward ASLV, which can put up to 150 kg. And then we have the most successful one in Indian history, that is PSLV, which can lift up to 1860 kg, which can easily put a car into space. It was 44 meter high and it's still being used. It can launch a satellite in sun synchronized orbit. Now sun synchronized orbit means a satellite will be put in particular orbit and the satellite will cover that part of the earth which is actually facing the sun. So the satellite will only be looking at that part of the earth where the sun is there. So it will only function in the daytime. It can also function under the geosynchronized transfer orbit, which we have already discussed. Then comes the another variant, which is GSLV, which can lift up to 2200 kg, and now the one that we are actually using, which can put up to 4 tons of satellites in the geosynchronized transfer orbit. If we look into the basic difference between the PSLV and the GSLV, we can look in the following matter. So the launch capability remains very different. So PSLV can launch up to 1.8 ton, while that too in the low Earth orbit, while GSLV can use the communication satellite which are very heavy in number, up to 4 tons. Number of stages, here there are 4 stages, here there are only 3 stages. Now for stages we have already discussed about, the stages increases from downwards. Then the propellant, here solid and liquid, here also solid and liquid, most specifically we are using the cryogenic. The first successful launch was 93, here 2001. The major notable missions are Chandrayaan-1 and MOM or Mars Orbiter Mission. Over here we have GSAT-14, we have GSAT-6, Chandrayaan-2 and in the future Gaganyaan also. Is it based on the cryogenic? No. It is based on cryogenic. And the last one is both were launched from the Sriharikota Satish Dhawan Space Center. Now the point is that one more thing which was mentioned in the article is the LMV-3 rocket. So LMV-3 rocket is nothing new. It is just the renaming of the Geosynchronized Launched Vehicle or GSLV Mark III. Now as you can see in this image, so this is your GSLV Mark III, which has now been called as LVM-3. It is a 3-stage medium lift launch vehicle. Medium lift means up to 4 ton. It can take higher payload capability than its predecessor GSLV Mark II. The recent launches included the Chandrayaan, and in the future it will be used to launch Gaganyaan, which is a manned mission by India. Now we come to the real issue, that what are the challenges being faced by ISRO in India. The first issue is budget constraint. ISRO operates on a relatively modest budget compared to many other space agencies including NASA, so ISRO's budget is just a fraction of what NASA is using. We have limited financial resources that can pose challenge in developing and executing the ambitious space mission. The second is the infrastructural limitations. So expanding the infrastructure to support the increased space mission and the satellite launches can be a challenge for India. We need to establish new launch pads, ground stations, and even the testing facilities, which actually requires more investment and planning. Then comes the issue of the space debris. Now, accumulation of the space debris, that is the older objects of the satellite which are no longer functioning in the space, or the space debris or the objects which are left by the satellites in the space, poses a significant challenge to the space agencies, including ISRO. Managing these small objects which are running at a speed equals to the satellites can be a cumbersome issue. These smaller objects or debris can cause damage to the existing and the most expensive satellites in the space. Then comes the issue of international collaboration. While ISRO has been successful in the international collaboration, such as joint missions with NASA and other space agencies, there is need to further enhance the global participation. For example, India does not participate with a like-minded countries like China, which is on more or less the similar technological upgradation as India do. However, has a small slight advantage. The collaboration with other countries can facilitate knowledge sharing, resource pooling, cost sharing, as well as providing India a demand to launch more satellites. Then comes the issue of the policy and the regulatory framework. So the space industry as of now in India requires robust policies and the regulations which can address the issues such as satellite spectrum allocation, commercial space activities, and international space law. So ensuring an appropriate legal and regulatory framework is actually in place can be a challenge for ISRO. Then comes the issue of the human resources. The demand of skilled scientists and the engineers in the space industry is high, and ISRO faces stiff competition from other global space agencies and even the private companies like SpaceX. So retaining the top talent and attracting the new talent in a particular financial constraint for ISRO's growth is a cumbersome problem. This is followed by public awareness and the perception. Building public awareness and support for space research and exploration is very, very important for ISRO. ISRO faces the challenge of effectively communicating its achievements and the benefits of space technology to the general public. The last one is the technological gap. While ISRO has achieved notable missions, we know Chandrayaan 1, 2, Mars orbiter mission and the future of Gaganyaan, there are certain areas where it still lacks the space technologies. For example, India had to wait more than 2 decades to get their cryogenic technology of its own. Developing the cutting edge technologies and keeping up with the rapid advancement in the space can be a challenge for ISRO right now. So the way forward in this regard could be that India had to invest more in the technology, in the funds, in the human resources, along with the collaboration with the international partners and bringing the new talent across the globe to get its technology sustainable for the future. With this discussion placed, let us now move to the next article for the day. This article of the Hindu newspaper appeared in text and context part on page 9th, which talks about that how we can understand the violence which are being faced by the healthcare professional in India. Now, this is a matter of health issues faced by the health sector in India, as well as important for your ethics paper, that who is ethically right and wrong in terms of the attack faced by the health professionals. Now, doctors and the medical students across India have been protesting against the killing of a female house surgeon, Vandana Das, by the patients and their families. So the patients and the relatives have now been turning more violent because of the healthcare systems not meeting up their expectations. And it is not always the death of the patient. It is sometimes even the loss of patience and the time being wasted by these families in the hospitals. Studies have shown that female medical professionals are more subjected to these risks than the male counterparts. Now the question is, who faces what kind of violence in India? So according to the systematic review done by the Journal of Postgraduate Medicine in 2020, developing countries are more prone, where more than 50% of the doctors are facing such kind of physical and the verbal abuse. So India is one of them. Most of the violence are being targeted toward the junior doctors as well as the residents. Now the question is where this violence is being targeted, mostly in the emergency wings and the intensive or the ICU wings or the departments with compromised mental faculties. Now, mental faculties here means when the resident doctors are too much under the pressure, they cannot handle the patients in the way they should be. So they are traumatized by their work culture. Under that work culture, they sometimes get frustrated, and under the frustration, they might take some wrong steps as well. Then comes that most of the perpetrators are actually the family members or the relatives of the patients. In 82% case, this was found out. Some perpetrators become violent over the emotional outburst of the hospital and their staff. Studies have also proved that or shown that female medical professionals with lesser years of experience are facing more risk of harassment. Again, now the question arises, what effects does this violence have on society as well as the medical professionals? Now, according to the National Medical Journal of India, 75% of the violence against the doctors is actually verbal and intimidating or the threats of being hit or being beaten up. Most of the doctors often say that this is part of their job, which should not be the case, because accepting the violence is not a good professional ethics. According to PLOS one study, 25% of the doctors have actually reported the violence, and only 10% of them have actually got their redressal being addressed. The symptoms of the post-traumatic stress disorder, anxiety, depression among the doctors has been reported because of such violence. The impact has already skewed with respect to the doctor-patient ratio. Less number of doctors in India, more number of patients has further deteriorated this problem. That in turn has led to less number of doctors approaching the rural healthcare system in India. Most of the doctors are trying to keep themselves in the high earning urban hospitals. And lastly, the impact has also been seen with respect to the life-saving medical and surgical interventions. where doctors are showing overcautious behavior. They are thinking that if they do something, or they might not be, or they may not, or if they may not be able to save the life of the patient, they might get beaten up by the family members. So they are becoming more cautious in providing the medical services or even going for the surgical intervention. Now the question is, what should be done? First, reducing the long waiting periods for the treatment, especially in the hospitals like AIMS. Availability and the accessibility of the medicines, test, financial aid should be prompt. Healthcare professionals need to work on their communication skills, which should be more empathetic, sympathetic, rather than just being a verbal excuse. Then the institutional measures should be that installing CCTV cameras as well as metal detectors in order to prevent the attackers bringing any kind of weapons in the hospitals. And lastly, ensuring that the counselors are available in order to provide the mental counseling to the patient and their relatives in case of high emotional distress. So if this kind of a topic is being asked in the ethics paper, you can well use this kind of arguments in order to substantiate that it is not everyone who is wrong on this part. Everyone should play their role: doctors, patients, family members, institutions, and society as a whole, in order to provide a good and long lasting solution to this problem. With this discussion please, let us now move to the last article for the day. This article of the Hindu newspaper appeared on page 8 and talks about the text and context matter with respect to the lack of teachers in India in the higher education. The article talks about the issue that why there are less number of teachers in the higher education in India. This topic is relevant for your GS paper 2. Issues relating to the development and the management of social sector and services under education. In 2020 mains examination, National Education Policy was asked, and in 2016 in the mains examination, the quality of higher education was directly asked in India. So such kind of topics may be repeated in the future, and one of the aspects of poor higher education in India is lack of good and quality teachers. Now the point is, what is the current status? Total enrollment in higher education although has increased to 4.14 crore in 2021. That is almost 4 plus crore people are in the higher education, which is 12 plus. Higher education gross enrollment ratio, that is the number of adults who are getting education between the age of 18 to 23 in India is 27%. So please don't get confused that 27% of India's population is getting the higher education, because 4 crore is not 27% of India. 27% here means, let's say if there are 100 people between the age of 18 to 23, out of these 100 people, 27 are in the higher education. The female enrollment has increased from 1.88 crore to 2.01 crore, which is a very, very good sign. Female GER has overtaken the male GER, and the gender parity shows a ratio of 1.05, which is for every 100 male members in the higher education, 105 are female. And in case of ST, SC, OBC participation, they have also shown the increase of 47% overall. Lastly, government universities have 73% of the total enrollment against the 26% in the private universities. So from this entire table, we come to know that yes, the picture seems to be quite improving right now. However, the real issue is not the enrollment but the teachers. So why we have shortage of faculty? The first, low number of PhD students. Most of the students in India who are graduating are looking for government jobs. If they are not looking for government jobs, they are putting themselves into private jobs. And most of the professionals coming out from the engineering and the management background are looking for the industry jobs rather than the teaching jobs. We have skewed numbers of the students opting for the teaching jobs. So most of them are looking for the professional jobs, going outside India, looking into the MNCs. We have professional versus conventional subject debates. That is, people are going for engineering, management, chartered accountancy, doctors and other courses rather than going for the conventional subjects like history, polity, geography, physics, maths and others. There's an acute shortage in the state universities because of the fund shortages. There is lack of well qualified faculties in the private universities. In most of the cases, they are underqualified. Most of them are not even the PhD holders as of now. And in case of smaller towns, institutions are not able to pay the higher salaries required by the faculties as per the UGC standards. This has further deteriorated the quality of education in those smaller institutions. Apart from that, the other challenges include that the quality of enrollment in India is still low. It is 27% against the global average of 33%. And if we talk about the regional differences, it is as low as 5% in Daman and Diu against 56% in Chandigarh. Students belonging to the ST group, scheduled tribe, constitute only 5.6% of the GER, which is a very, very low number. As far as quality is concerned, so only 3 Indian institutions rank in the top 200 as per the QS World Ranking. As far as employability of the graduates are concerned, so as per the Indian Skill Reports 21, less than half of the graduates are actually employable. See, the word is employable, not employed. So they are not qualified to be employed anywhere. So out of every 100 graduates in India, 50% are redundant. Even more than that are redundant in order to provide the employment. As far as research and innovation is concerned, so we are very, very backward in that case. Islands of excellences are created where IITs, IISc and IIMs are taking the top seats and the common graduates colleges are lacking behind. Then we have the governance issues. So the management of the Indian education faces the challenges like over centralization by the government, lack of autonomy, transparency, fee structure is poor, research aptitude is poor, most of the students are going for the brain drain and many others. In this regard, government has provided certain initiatives. The first one is creating the scheme of Institute of Eminence. Under this scheme, higher educational institutions are empowered and are provided the best teaching and the research institutions. 10 public and 10 private institutions are to be identified under this scheme, which are going to emerge as a world-class teaching and the research institutions. Government institutions under this scheme are going to get funds up to 1,000 crores, which is a very, very good sign. The second initiative by the government to improve the higher education is HEFA, which is Higher Education Financing Agency. Under this scheme, a joint venture of Ministry of Education and the Canara Bank was created to finance the capital assets in the premier education institution in India, for example, the infrastructure. It is going to revitalize the infrastructure and the system in the higher education, going to meet the needs of the new investments in research and related infrastructure. And the last one is Rashtriya Uchchatar Shiksha Abhiyan. Uchchatar means higher education. This is a centrally sponsored scheme aimed at providing the strategic funding to eligible state higher education institutions. Under this, the central funding in the ratio of 60:40 for general category states and 90:10 for special category states and 100% for the union territories would be provided to increase the outcomes. So that's all for today's Daily News Simplified. Stay tuned for more such updates. Thank you.